Hi there, this is Chris from Nourish Balance Thrive. I thought I'd make this short video to explain some of the biochemistry investigation that I've been doing recently on some high-level elite athletes. And this particular example comes from a former Ironman who developed an atrial fibrillation and had an ablation in 2014. And he's doing pretty good. He doesn't really have any symptoms to speak of right now. He just wants to make sure that he's doing as well as he possibly could. And he's done quite a lot of testing with me. And the first thing we did was some blood work. And a couple of things that popped out of me straight away on the blood work was his ferritin and serum iron, which was elevated. And I started to wonder about maybe iron overload. And he went on to do a urinary organic acids test. And this test is super cool. So the blood work, obviously, you have to go to LabCorp and get some blood drawn. The urinary organic acids, you don't have to do that. Like, I can send you a test kit in the mail, and then you collect some pee first thing in the morning, and then you freeze it, and then you send it into the lab. And then this PDF report comes back to me electronically, and then I can get people on the phone and start talking about it. And there was one main area of concern I had for this particular result. And you can see at the top of the page here, markers number 28 and 29, that's p-hydroxyphenol lactate, and 29 is 8-hydroxy-2-deoguanosine. And I think these are super interesting markers for anybody that's interested in health and longevity. So p-hydroxyphenol lactate is a marker of cell turnover. And when you see this elevated, it means there's a higher than expected rate of cell turnover. And so if you were to do this test in a child, and in fact I saw one at the weekend that belonged to a 12-year-old girl, and she also had an elevation of p-hydroxyphenol lactate, but that's completely normal because she's growing and she's turning over cells quickly. Now in a 50-year-old triathlete, this is not normal. Something's going on here. And then below that, the 8-hydroxy-2-deoguanosine, if you remember back from biology, guanosine is one of the components inside DNA. So what this is telling you, this is a breakdown product of DNA. So oxidative stress is actually destroying this person's DNA. And there's tons and tons of good evidence in the literature. If you're the sort of person that likes to do research, then go look up 8-hydroxy-2-deoguanosine, and you'll see it's linked with cancer and diabetes and pretty much any chronic disease that you can think of. And in the literature, it seems like 5.0 is the number you're shooting for to be healthy. And this guy, as you can see, is at 5.3. So something's going on here. A ton of oxidative stress. And then another marker which I thought was related and also very interesting was marker number 34, which shows an elevation of pyroglutamate. And pyroglutamate is a metabolite and a kind of a product that builds up in the urine sample when there's insufficient glycine to make glutathione. So this diagram here shows that the goal is to take the glutamate and the cysteine and combine it with glycine to make this really important endogenous antioxidant called glutathione. So endogenous just means inside your body. Your body should be making this compound to balance out or to mitigate the harmful effects of the oxidative stress that we've already seen on the organic acid test. And that's not happening for this guy. Instead, we're seeing this build-up of pyroglutamate. So we really want the glutathione. Instead, we're getting the pyroglutamate. And I think the reason this is happening is because there's insufficient glycine available. Glycine is just an amino acid to make the glutathione. And okay, so where does glycine come from? Well, it comes from foods like bone broth and things which are rich in skin and connective tissue. So, I think that glycine is going to work really well for this guy as a supplement until he figures out how to get more bone broth into his diet. And then finally, I did an additional investigation to find out whether he really does have iron overload. And I think the answer is yes. The total iron binding capacity is very low, which indicates iron overload, or hemochromatosis as it's sometimes known. And the percentage transferrin saturation, you can think of this marker as the number of seats on the iron bus which are occupied. And in this case, the bus is full to overflowing, which means there's lots and lots of iron. So there's a fairly simple solution for this problem, and that's to just go give blood. And obviously you want to monitor it. You don't want to do too much of a good thing because that could lead to other problems. But really the solution is pretty simple. And I think the other thing that this guy can do, and I think he is going to do it, is order the 23andMe genetic test. And there's some mutations in the HFE gene which affect how efficiently we absorb iron. And it's a really common genetic mutation. In fact, it's the most common genetic mutation in the US, with up to 1 in 200 people having it. And I think it's an interesting gene, and I've been doing some research on it, and I hope I'm going to do a podcast on this in the future. But you can imagine that maybe in years gone by, it was an evolutionary advantage to be better at absorbing iron and therefore making red blood cells. You know, maybe you were a warrior and you got injured frequently and you needed to constantly be absorbing iron and making more blood. And now maybe that's not an evolutionary advantage because males in particular, they never bleed. So it causes problems. So absolutely, the iron overload here, you think of a rusty nail, it's iron is a pro-oxidant. It causes oxidative stress. So it's also an essential nutrient. We would die if we didn't have it, but too much is absolutely a problem, and it can cause the oxidative stress that we've seen here in the organic acids. So anyway, I thought this would be interesting to you. I hope you think it is. Do let me know in the comments section, and maybe I'll do some more of these videos.